At first glance, it looked like just another rock, a wandering traveler from the void. The universe has always been full of such things: icy comets, asteroids, forgotten fragments from the formation of stars. But then, the anomalies began to stack up. Its velocity was extraordinary, pushing well beyond the expected limits of natural debris. Its path was unusually precise, almost too exact, too clean, as if plotted rather than the chaotic randomness expected from cosmic wanderers. And its surface, reflecting light in ways no typical asteroid could, suggested there was more to this mysterious visitor than raw stone and ice. And when scientists traced its route backward through the darkness, recalculating again and again to be certain, they realized something unsettling. It wasn't just passing through. It was heading straight for the beating heart of our planetary neighborhood. That realization set off waves of unease across observatories worldwide. Suddenly, what had seemed like a routine cosmic event became a mystery layered with implications no one was prepared to face. The James Webb Space Telescope turned its gaze toward it. Webb, humanity's most advanced eye into the cosmos, had been designed to peer across billions of years and see galaxies being born. Yet now it was directed at something much closer, much smaller, but perhaps infinitely more important. And what it began to reveal was not just unprecedented. It was something we may not be prepared for. Because if it's not just a visitor, if it's something watching us, then the entire definition of deep space, of our place in the cosmos, might be about to change forever. Between July 10 and July 14, 2025, the ATLAS tracking system locked onto it. A mysterious interstellar object that would quickly be named 3IATLAS. But unlike the countless icy wanderers catalogued over the years, 3IATLAS defied every expectation. It was moving at over 100,000 parsecs, a speed consistent with known interstellar objects, but remarkable nonetheless, particularly because it carried such precision in its approach. Yet, despite its velocity, it followed no known orbital path. And when its origin was backtracked, the results only deepened the puzzle. It didn't point to the Kuiper Belt or even the farthest reaches near Neptune. Instead, its trajectory came from deep interstellar space, a region so remote, so empty of nearby stars, that it had likely been traveling for millennia before entering our cosmic neighborhood. That fact alone was astonishing. But the timing, that was the first red flag. Before 2017, humanity had never detected an interstellar object passing through our solar system. Then, suddenly, in the short years since, we've encountered two confirmed ones. And each one has been stranger, faster, and more baffling than the last. Oumuamua in 2017 was elongated and moved with unexplained acceleration, as if something unseen was nudging it forward. Borisov in 2019 was faster, more volatile, and clearly different from anything seen before. And now, 3IATLAS, brighter, more precise, and far more unsettling than its predecessors. The James Webb's instruments began dissecting its light signature with ruthless precision. But the data only deepened the mystery. The object's reflected brightness suggested it could be massive, something of considerable scale. Yet, contradictory scans showed it was surprisingly small, roughly the size of Oumuamua, about 100 meters long. This contradiction hinted at a surface unlike anything natural, possibly more reflective than typical rock, though not necessarily polished metal. Something about it refused to fit neatly into existing categories. Harvard astrophysicist Avi Loeb, who famously speculated that Oumuamua could have been artificial, immediately raised the same concern here. Look for non-gravitational acceleration, he urged. Because if it was propelling itself, that meant intent. Intent meant design. And design meant a maker. From the start, 3IATLAS seemed to be a cosmic hybrid, combining the inexplicable acceleration of Oumuamua with the comet-like inbound trajectory of Borisov, yet fitting neatly into neither category. Its motion was deliberate, almost surgical. Unlike natural fragments, which tumble chaotically as they journey through the void, this object rotated with unnerving symmetry. One side consistently absorbed more heat than the other, almost as if it had a structure optimized for thermal regulation. Webb's sensitive thermal sensors confirmed it, a faint, constant signature, structured, not random. And then came the most unsettling discovery. It was adjusting its course in small, precise increments without any detectable jets of gas, dust, or debris that would explain such changes. This wasn't a drifting rock being nudged by sunlight. This was something steering. Spectral analysis from NASA's Goddard Space Flight Center shattered any remaining assumptions. The readings showed carbon-based compounds and arrangements far more complex than expected for natural geology. Though not definitively artificial, the data hinted at unusual internal structures hidden beneath its surface. Even stranger, complex electromagnetic fluctuations were detected, patterns not normally associated with natural objects. This was no mere lump of cosmic debris. It was potentially a machine. And if it was a machine, then it meant it had a maker. At this point, whispers began circulating among scientists across continents. These whispers did not focus on what it was. Instead, they asked who had sent it, and why. Then, without warning, the flow of information slowed. Agencies that had been sharing updates openly, NASA, the European Space Agency, and others, suddenly began limiting their data releases to closed networks. Public databases updated less frequently. Observation logs became less detailed. Independent researchers reported delays in telescope access. Journalists probing for answers were met with carefully worded statements that emphasized ongoing analysis over definitive conclusions. This cautious approach only ignited new theories, that something had been found, something too disruptive to release without careful consideration. In space, silence can be more revealing than any official statement. If 3IATLAS was truly artificial, its existence could upend more than just astronomy. It could challenge politics, global security, and humanity's entire understanding of its place in the cosmos. For centuries, the night sky had been indifferent, vast, and empty. Now, in the span of just a few years, it seemed to be filling with purposeful visitors. Some scientists quietly speculated about patterns. 2 confirmed interstellar objects in under a decade, each stranger than the last. Was this random? Or was it the slow, deliberate unfolding of a plan? And if so, was 3IATLAS the next phase, or the final one? As James Webb continued its silent vigil, a darker, more unsettling hypothesis began to take hold among those still analyzing the trickle of data. What if 3IATLAS wasn't simply passing through? What if it had been waiting, triggered to become detectable only once humanity reached a certain threshold of technology? Its exact arrival at this precise moment in our advancement seemed too perfect to dismiss. For billions of years, the galaxy had been silent. Then, almost immediately after we developed tools like JWST capable of detecting faint objects from deep space, something appears. Quiet. Deliberate. Impossibly precise. This didn't feel like a message. It felt like an evaluation. A probe, not here to talk, but to observe, maybe even to judge. The more data Webb collected, the more questions replaced answers. Was it mapping our planets? Studying our defenses? Or was it simply watching to see what we would do? The thought that chilled scientists the most wasn't that we had found something. It was that something had found us, and had possibly been waiting for this moment all along. The reflective properties of 3IATLAS's surface became the next major point of investigation. To the untrained eye, it was simply shimmering oddly, reflecting more light than it should. But to scientists who knew what they were looking at, the data revealed something extraordinary. The reflectivity varied in a way that suggested dynamic thermal management, capable of altering its infrared signature depending on its orientation toward the sun. This wasn't random. This wasn't chance. This was controlled heat regulation, something spacecraft designers on Earth spend decades perfecting, and even then, only on relatively small scales. The object's rotation period, too, was telling. It was consistent, almost clockwork, suggesting a stable